Okay, this is 9.2. Today we're multiplying polynomials together. You are going to need your graphing calculator for later on in the notes, so you might just want to grab it now, or you can pause the video later and grab it. So example 1, we are going to multiply this monomial, 3x cubed, to the polynomial. And what do you need to do when a number, back in the old days, a number was next to parentheses? You had to distribute it to each term in the parentheses, and that's what we're going to do right now. So the first thing that I'm going to do, I personally would make these plus -1, plus -7, and plus -3. They're not going to do that in their example down here, but I find that that would be helpful for most students. You're not going to need to show this work each time you do a problem, but it's on here just to help you for this first example. So what we're going to be doing is we're multiplying 3x squared times 2x cubed. Then we're going to multiply the 3x squared, and they move the minus sign out in front, and they're going to multiply it by x squared. Now, if you had already moved these to plus and negative, you'd have a plus sign in between and be multiplying it by the negatives there. Actually, let's just do that because this is kind of confusing when they have the minus sign there. So we're going to, it's a positive here, right? That's a positive number. What are we multiplying it by? We're multiplying it by -1x squared. The next one, it's a positive. We're adding 3x cubed times the next term, which is -7x, and 3x cubed times -3. So each term is going to be multiplied by 3x squared. Now, maybe it's dawning on you why we did chapter 8. Because we have to multiply these together and know what to do with the exponents. What do you do when you multiply this together? It's chapter 8 all over, isn't it? So 3 times 2 is 6. X cubed times x cubed, you add the exponents and get x to the 6th. Good thing we did chapter 8 for practice. Yeah, now see, you're loving it. All right, 3 times -1 is -3. They already made it a minus sign there for us, or we could have plus a negative. X to the 3rd times x to the 2nd is x to the 5th. 3x cubed times -7x is -21 x to the, there's a 1 there, so it's x to the 4th. And my last one is -9 or -9x to the 3rd. So either you have minus signs in between them or plus a negative like I have there. Okay, so why don't you, let's do this. We'll do one practice here. Checkpoint number 1, go ahead and pause the video, see if you can do it. Okay, so I put my coefficients of 1 when they weren't there. I added a negative. I made my exponent of 1 here just to help me out. And I'm distributing each one. So I get 2x to the 5th plus -10x to the 4th plus 6x cubed plus -14x squared. So if you're not sure how I got that, come see Mrs. Wyman if you're in class today or tomorrow. Come see me. So now in example 2, we're going to multiply polynomials together. And I started to show you this in chapter 8 when we were doing problems like this. Z plus 2, and maybe it was raised to the 4th power. And some of you were trying to make that z to the 4th plus 2 to the 4th. But remember, I had shown you that each term gets multiplied by every other term. So that's what we're going to do now. We're going to show it both vertically and horizontally. And you can decide, again, which method you like the best. So this is the vertical method. Here are my two terms. It's a trinomial times a binomial. And they have listed them out vertically. What you're going to do is, back in old multiplication, you're going to multiply each term by this -5 here. I'm going to make it plus a negative as well as my other terms, just to help me out. So each term is getting multiplied by -5 first in this line. So -5 times -3 is 15. -5 times -6a is 30a. -5 times 1a squared is -5a squared. So that was my -5 line. The next line over is the 2a line. So each term is going to get multiplied by 2a, and I line up my answers just like we did a long time ago in multiplication back in elementary school. You line it up over 1 because we were over 1 there. So 2a times negative 3a is negative 6a. They made a minus sign there, or I can make it plus a negative. 2a times negative 6a is negative 12a squared. Sorry, 12a squared, because those are exponents of 1, remember. And then 2a to the first times 1a squared is 2. 1 times 2 is 2a to the third. And now you know why we did 9-1, because we need to add these together to get our final answer. So our final answer is 2a cubed plus negative 17a squared plus 24a plus 15. So that's vertical format. Horizontal format we're going to do with B. And basically what we're going to be doing here is we're going to be multiplying each term in this one to each term in that one. We're going to make basically little problems up like we had here. We had a monomial times each one here. That's what we're going to do here. We're going to do a monomial times this monomial times this, and so on. So it's 3b squared was the first term here, and he gets multiplied by each one there. I'm going to make this plus a negative down there. Then the negative 2b, or the minus 2b, is plus negative 2b, gets multiplied by each one there as well. And then, finally, the plus 5. The 5 gets multiplied by each term in there as well. So I'm going to make this plus a negative, and this one plus a negative. Now you need to go through and distribute each one. So 3b squared times 5b is 15, b to the third, plus sign. 3b squared times negative 6 is negative 18b squared. Moving on to my purple. Negative 2b times 5b is a negative 10b squared because they are each to the first power. Negative 2b times negative 6 is a positive 12b. And distributing the 5, 5 times 5b is 25b. 5 times negative 6 is negative 30. You're not done because you have some like terms. So now what you need to do is what we did back in 9-1. You can use your color coding. 15b cubed is by itself. And then I need some more colors here. Let's see what. Now I have a negative 18b squared and a negative 10b squared, so they make negative 28b squared. I have two terms that are both b terms, 12b and 25b. They make 37b. And negative 30 is out there by itself. I'm just going to tack it on there in orange. Plus negative 30 or minus 30. Okay, not hard. Lots of places to make a mistake, yes. So you decide which method works for you. I need to see work in some sort of fashion. So example 2, you're going to do that however you want right now. Pause and then come back and check. All right, so your solution should be, let's hope, 2a cubed plus 13a squared plus 7a minus 12. So the work I'm showing is taking each term in the first polynomial, multiplying it by each term in the second polynomial. So I multiplied the 1a squared, and I got these two terms when I multiplied them by those two. Then in green, it's my 5a getting multiplied by those two terms and getting those two results. And then in orange, in purple, I have negative 4 being multiplied by 2a and by 3 and getting those. Once I get all the terms after distributing each thing through, then I add my like terms together. The 2a cubed was by itself. The a squareds make 13a squared. The a's make 7a, and the negative 12 gets rewritten. Okay, so now we're going to talk about binomials. And when we multiply binomials together, we use something called FOIL. Okay, FOIL. It's super fun, and FOIL stands for first, outer, inner, sorry, let's move it over. First, outer, inner, last. That way you can keep track of, did I multiply everything by what it was needed to be multiplied by? Okay? So let's do the long version of FOIL, and then we'll shorten it up. So 2C times 1C. Those are the firsts, right? First term times first term. What do they make? They make 2C squared, because the exponents on those C's are 1. Then we do the outers. 2C times negative 9 is negative 18C. Then we do the inners. 7 and C are the terms on the inside of there. So it's 7 times C, which makes 7C. And finally, the terms that are both last, which are 7 and negative 9, and they make negative 63. When you multiply two binomials together, you will get a trinomial. Right now it doesn't look like it's a trinomial, but look at my two middle terms. They are like terms, and they make negative 11. So my final answer is 2C squared plus negative 11C plus negative 63. Okay? So basically what I'm going to need from you is these last two lines each time. You can show that top line for your work if you want, or you can just skip it and go to the last two. All right, so pause, do checkpoint 3, you can do it. Okay, after you FOILed, your first terms would have made 5m squared. Your outers make negative 4m. Inners are 15m, and lasts are negative 12. So that simplifies to 5m squared plus 11m plus negative 12 as your final answer. Give yourself a pat on the back if you got it. Good job. Okay, so example 4. I know these notes are like crazy long in these two sections, but remember, this is like building blocks, baby. We need all of this stuff for our future work. So example 4, it has area, and it says the dimensions of a rectangle are x plus 4 on one side and x plus 5 on the other. Write an expression that represents the area of the rectangle. So you know your formula for area of a rectangle is length times width. I'm guessing the length would be which one? The x plus 5, because this one's a little bit longer. This one's only x plus 4. Now, we don't want to just leave it like that. We want to FOIL it out, so if somebody tells us what x is, then we can just solve easily. So we're going to FOIL it out. X times x is x squared in my first. My outers are x and 4. They multiply together to make 4x. My inners multiply for 5x, and the last terms make 20. So that is x squared plus 5x plus 20. And we're going to check it using a graphing calculator. So grab your graphing calculator. Oh boy, we'll see if I can get this to show up without too much craziness on the screen. Let's see, that's not bad. All right, go to your y equals, clear it out if anything's in there, turn your plots off, all that good stuff, and you're going to put in the first one that we have here. The first equation is y equals x plus 5 in parentheses, so your parentheses is above 8, x plus 5 parentheses, and then open it up again, x plus 4. Close it off. Okay, so we're going to graph it in a standard window. Our standard window is negative 10 to 10. If yours isn't in a standard window, remember you go to zoom, and number 6 is standard window. So that's what it looks like. It's called a parabola. Woohoo! These are quadratic functions, and they, when you plug in values for them, make this nice smooth curve. We're going to learn all about that in your future. Now, my next graph, if I did my math right, should be right on top of this guy. The next one is whatever I got when I FOILed this out. So I got x squared, and the squared function is diagonal to the 7, or you can use the caret key and then the number 2. Oops, and I'm putting it in the spot in my y1, so let's put it in y2. All right, so x squared plus 5x plus 20. If I did my FOILing right, when I hit graph, they should be identical. It should be the same curve twice. There's my first one. It's still processing. right? But no second one shows up. If I hit trace, I'm on my first curve, and if I hit down, I'm on my second curve. It's the same spot on both curves. I can cursor over. It was at the y-intercept, you could see down at the bottom there. Oh, did I go too far? Trying to get my cursor to show up on the screen. No. Oh, goodness. There we go. Okay. So, oh, that's in my y-intercept again. Okay, so wasting lots of time here. I can't get it to quite show up on the screen. So we could zoom out a little bit more. We'll do that real quick. We're going to zoom out number 3. So I hit zoom and then number 3. You can see just where I'm at right there. And I'm just going to hit enter, and now it zooms out. It's shifted way over. If I hit trace, it should be the same graph. Let me pause and figure out what's going on with my calculator. All right, this was a perfect error analysis issue. I'm sure you have figured it out long before me what the error was. Clearly, I knew there was a problem because my graphs were not the same. They looked like they were the same at first. And you probably were like, Mrs. Wyman, you are so goofy because you made a huge mistake. What was my mistake? What's 4 plus 5? 9. Why in the world did I write 5? So there's my 9, which is why my graphs are not the same, because I did not type in the same equation. Let me fix it. Sometimes things work out perfectly because I am so happy you got to see that error and got to analyze what happened. There it is. I've zoomed way out so that I can prove that I do not have a different line, and if I hit trace, you can see that I'm blinking right down here. See that it's blinking down there? It's hard to see. I'll go over. There's my Y1. If I hit down to go to my Y2, it's the exact same spot on the curve. Okay, so there was my graphing calculator to prove that those two are identical. I FOILed properly. Okay, so just to kind of fill in their blanks there, Y1 was x plus 5 times x plus 4. Y2 was x squared plus 9x plus 20. The graphs coincide. They are the same. Coincide, big word of the day. So the product of these two is x squared plus 9x. All right, sorry for the all call. X squared plus 9x plus 20. Okay, so go ahead, do the same thing below. Check it on your graphing calculator. Make sure that you have the correct answer. Come back and see what you have. Okay, you should have gotten x squared plus 14x plus 33. And here again, in my zoomed out window, is the curve, the parabola, for those two different equations, but actually it's the same one in disguise. And it worked out perfectly this time. Okay, last page. Maybe you should have a quick little break if you haven't had one already. So it's the longest notes ever. I'm sorry about that, but it is completely and totally necessary. Okay, so we have a walkway. You're making a walkway around part of your swimming pool. The dimensions of the swimming pool and walkway are shown in the diagram. So here's our pool, there's our walkway. You're going to write a polynomial that represents the area of the pool, and then they want to know what is the area of the swimming pool if the walkway is 2 feet wide. So we're going to break this guy down. So step 1, write a polynomial using the formula for the area of a rectangle. Area is length times width, okay? Well, look at what they've done. They have given us the entire length, including the walkway right here, including that walkway, is 25 feet. The length of the walkway, we don't know what it is. It's x. So this part of the pool is 25 minus x. We have to take the walkway off of the length. Same with the width. It's 18. However, there's this part of the walkway included in there, so this is 18 minus x there. Okay, so we know the formula for area of a rectangle is length times width. Awesome. Now we're going to multiply our two terms together. So 25 minus x, you may want to make it plus a negative 1x right now, and 18 plus negative 1x, and you're going to FOIL it out. So 25 times 18 is 450. 25 times negative 1x is negative 25x. Negative 1 times 18 is negative 18x. And here's where you want to make sure you did this right. A negative 1x times a negative 1x is a positive 1x squared. Negative times negative positive, x to the first is x to the second. So my final answer here is x squared plus negative 43x plus 450. That's the area of a swimming pool written as a polynomial. Now, if they tell us that walkway is 2 feet wide, where does the x go? Where does the 2 go? I just said the answer. It goes in for x. So we're going to do 2 squared plus negative 443 times 2 plus 450. And when you work all that out, it is equal to 368. So the area of the swimming pool is 368 square feet. Remember, area is feet squared, so you write it out in words as square feet or feet squared. Okay, same idea for number 5, but this time the walkway is going around the entire pool. So what are you going to do for your expression there? Go ahead, pause it, and see if you can write the expression before you FOIL it out. All right, now I know some of you are probably ready to stop with notes, but I need to tell you, before I show the answer to this last problem, there is one more very important detail that you're going to need to do in your notes because it's going to start helping you with what we're doing in the future. So do not stop right after you see the solution to this problem. You need to listen to the last piece of notes. I know they're the longest notes in history. I'm sorry. Okay, so here is my binomial times my binomial. You're going to subtract a 2x because there's an x on each side now because it went all the way around. And when you FOIL it out, you're going to get 660 minus 60x. Sorry, there we go. I have a notice pop up. Minus 4x plus 4x squared. So putting that all together, it would be 4x squared minus 104x plus 660. Okay, so there's my polynomial, and plugging 3 in for the x's, you will get 384 feet squared. Okay, so the last thing I want to show you, I want to start putting into your mind one other way to FOIL. And you're probably going to look at this and say, oh, I already got FOIL, it's too easy. But when the problems get much harder, this method is lovely. So what we're going to do is we're going to make a square and we're going to divide it into 4 parts. And I'm going to do this same problem here, but I'm going to use it with my little box method. So I'm going to write, each term is going to get its own little side of the square. So here's m plus 3, and it's a positive, so I just have an m and a 3 in each spot there. And then it's 5m, interesting 5m, and negative 4, so the minus 4 goes there. And now each square is going to be a product of the part that is in its row and its column, basically, okay? So what is 5m times m? It's 5m squared. What is 5m times 3? It's 15m, okay? Next row, first column, negative 4 times m, negative 4m. Negative 4 times 3 is negative 12. So when you write your final answer, you're going to get the same thing. 5m squared plus 11m, because these two make 11m, plus negative 12. I just want to put that in your mind right now, because when we start factoring in Chapter 10, we are going to be so happy that we started using this now. All right, notes are finally done. Longest notes in history are over. Continue on to your next step.